Hello, dear students. Welcome back to my channel. So, in today's session, we will be discussing the PYQs from the Newton's laws of motion. So, I have created two kind of lectures for it, right? Hello, dear students. Welcome back to my. So, in first lecture, that means in today's lecture, we will be discussing some numerical, some PYQs, and most probably day for tomorrow. In second series on second lecture, we will be discussing the rest PYQs, right? So let's start today's lecture. Second. So I think we need to start now. Okay. So as I just told you in the beginning of the lecture, we will be discussing the PYQs from NLM, and the PYQs will be from 2004 to 2024, right? And you also know that my name is Shakoor Mustafa. So here is my name also written there. So let us start with the first numerical. First, I need to check the visibility of the lectures. Then we can start. Okay, so let's start. The first numerical, like a box of 5 kg is pulled by a cord up along a frictionless plane, okay, inclined at 30 degrees with the horizontal. The tension in the cord is 30 Newton. The acceleration of the box is, okay. So what we need to find out? We have to find out the acceleration in the box. How we can get it? First of all, we need to make the diagram, right, as per the question demand. So I will make the diagram. Okay, so we have a box. We have a box like this, and the box mass is 5 kilogram, 5 kg. Then, so here we have a cord here. This, and this angle is given to be 30 degrees, right? So we know that one thing that we know, and that is this will show my mg. Sir, this is my mg. Okay, and so if this is theta, this is also theta, so it will be equal to mg cos theta. This is normal reaction, and this would be what? Mg sin theta. This one is my tension. Tension is given to be how much? Actually 30 Newton. This one is 30 Newton. We have to find out the acceleration. So we know that F is equals to mass into acceleration. So acceleration would be equals to force net divided by the mass. One force is 30, one is mg sine theta, right? And the object is going upwards. Clear? So I can write tension will be dominant. So I can write T minus mg sine theta whole divided by the mass. Clear? Yeah. So what is tension? It is 30 minus mass is given to be how much? Mass is 5. Okay. G is 10. Now we have sine 30 and sine 30 is 1 by 2 whole divided by mass is given to be 5. 2 ones are 2, 2 fives are 10. It would be 30 minus 25. That would be 5 and 5 by 5 is 1. So I can write 5 by 5. It is 1 meter per second square. So I guess option D. Yeah, option D is the correct answer. Okay, simple. Now let's move to the next numerical. And the numerical like a horizontal force 10 Newton is applied to a block A as shown in the figure. The mass of block A and B are given to be 3 kg and 2 kg and 3 kg. The block slides over a frictionless plane that is nu equals to 0. The force exerted by block A on block B. So we have to write what? We have to write force on block, force by block A on block B. That is force on B due to A. We have to find out this. So is it equal to mass into acceleration? Yes. So I can write mass. Mass of the body on which force is being acted. So it would be mass of B. Then we have acceleration, but it is common acceleration. Clear? So what we need to find out? This force, right? So mass is given to be how much? I guess 3 multiplied by acceleration. So how we will find acceleration? So we also know that F is equals to mass into acceleration. So acceleration came out to be force net divided by mass. What is force net? It is 10 Newton. Total mass is 5 kilogram, right? So I get my answer will be 2 meters per second square. Now put the value here. I guess it will equals to 3 into 2. It came out to be how much? 6 Newton. Right? So 6 Newton is my correct answer. Okay. So next numerical. So the next numerical is a block of mass 2 kilogram is placed on inclined rough surface AC. Okay. Of coefficient of friction nu. If G is 10 meters per second square, then net force of the block will be. So we have to find out the net force. We have to find out the net force. Okay. Look. So what we can do, right? If let us suppose the block is inclined rough surface as shown, the coefficient of friction is okay. So what I can write right now, I can write, sir, it is one component will be like this. So it would be mg sine theta, and one will be upper component that will be my friction, right? And it will be nu n. This will be my mg cos theta, and this will be my n. So can I write? So it will be nu n equals to mg cos theta. So I have only two forces now. This one is nu mg cos theta, and this one is my mg sine theta. What is the value of this one? Mass is given to be 2, g is 10, and sine 30. What is sine 30? Sine 30 is 1 by 2. Okay, now this one. Nu is 1 by root 3, m is 2, g is 10, cos 30. Cos 30 is root 3 by 2. 2, 2 cancel out, 3, 3 cancel out. So my answer is 10 here. 2, 2 cancel out, my answer is 10 here. You can see now. So we have the force balanced. So what will be F net now? Sir, F net would be equals to 0. F net will be equals to 0. There is one more approach, right? One more approach. B. This is A and B. How we can get it? If I can write what is tan theta. So, sir, it is tan 30 degree. Is tan 30 degree 1 by root 3? Yes, sir. And it is equals to nu? Yes, sir. If my tan theta is equals to my coefficient of friction, in the particular case, I can write it as a no motion. Right? No motion. If there is no motion, so body will be at rest. That means my force will be 0. We can do like this also, right? Next numerical. A 1 kilogram object strikes a wall. Okay, so first of all, I have to make the wall. Okay, this is my wall. Now, 1 kg object. Here is my 1 kg object. It strikes a wall. My velocity is given to be how much? Velocity is 1 meter per second. At an angle 60 degree with the wall. So this angle is given to be 60 degree. And reflected at the same angle. So like this. 60, this will be also 60 then. Speed is same, that is 1 meter per second square. Sorry, 1 meter per second. Huh? Okay. Then we have to find out if it remains in contact with the wall. So delta t is given to be 0.1 second. We have to find out force. How we can get the force? Sir, we know the equation force equals to change in momentum by time. What is change in momentum in this particular case? So I can write it would be equal to 2 mv sine theta whole divided by delta t. 2 is 2, mass is given to be how much? 1. V is 1. Sine 60 is root 3 by 2 whole divided by 0.1. So 0 point cancel out here. I will write 10. So 2 cancel out. So my answer is 10 root 3 Newton. 10 root 3 Newton. I guess option number C is correct. Right? Next numerical. A football player is moving southwards. Okay, I need to first off make the diagram like this. Okay, east is I cap, west minus I cap, north j cap, south minus j cap. Okay, so a person is going like this, right? A football player is moving southwards. Southwards means minus j cap. Okay, and suddenly turns eastwards. East is I cap. Speed is same, it is v. To avoid an opponent, the force that acts on the player via turning is. So we have to find out the direction of force. So I can write some direction of force. Direction of force will be equals to direction of momentum change. How to find momentum change? Delta P. Delta P, right? So what is P initial? Sir, initial P is it is going in the southward direction. It is MV. So can I write here MV, but I guess it is in minus j cap. Yes, sir. What is final? MV plus I cap. So is delta P equals to P final minus P initial? Can I write it MV I cap minus MV minus j cap? So I will write MV I cap plus MV j cap. I will write MV I plus j. What is I plus j? I plus j, it is the first region, right? First quadrant. I plus j. That means east north. Northward, no, wrong. Northeast, yes, it's correct. Southwest, wrong. No, I guess it is northeast, right? We can do it like this. Next numerical. Calculate the maximum acceleration. So we have to find out maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is. So that means if we have something like this, clear? And the body is going with some acceleration A, and here we have a person, right? Yeah. So due to this acceleration, a pseudo force will act, and I can write the friction force will act. So if this body needs to be stationary, so the friction force should be the limiting friction. That means the force acting on the body, the force should be balanced by the limiting friction. So in this particular case, the body will remain at rest. So can I write my force should be equal to FL, limiting friction, right? So force equals to mass into acceleration. And what is FL? Is it nu s times n? Yes. So can I write ma equals to nu s? What is n? Is it n mg? Yes. Cancel out. So A came out to be nu s. What is nu s? So it is, I guess, 0. Yeah, this one. Yeah? 0.15 multiplied by 10. So 1.5 meter per second. So here is my answer. Option number B. Correct? Easy, right? Next numerical. Okay. So in the diagram shown, the normal reaction force between 2 kg and 1 kg is. Okay. So I will take 1 kg block. So this will be having force F2, that is 18 Newton. So we will be having more forces. So one force will be, this body will just act as internal force to it, right? So I will have the force F, let us suppose this is F. One more force will be downward, that is mg sine theta. What we need to find out? This F. But due to this one, we have some component now acting on it. So how we can get it? So I guess there is a one option by which I can get it, right? How I can get it? So can I write? Sir, is it F, that is this F, that we have mg sine theta minus F2 is equal to mass into acceleration. What is F? We don't know. What is M? Is it M given to us? Yes. Is it? Yeah, to 1 kg. 1. G is 10. Sine 30 is 1 by 2. Minus what is F2? Sir, F2 is given to be 18. What is M? M is given to be how much? 1. And A we don't know. 2 ones are 2, 2 5s are 10. F minus 18 plus 5 minus 23 is equal to A. So F came out to be 23 plus A. Now how to find A? It is common acceleration. A is what? Common acceleration. If you closely observe this figure, right? So I can break down and I can write the forces that is being acted on it. So look now. 1 here, I can write on it now. Look, it is F. So I can write F1. So there will be one force like this, and it will be M1 G sine theta. One more force, M2 G sine theta. One more force, M3 G sine theta, and this one. So I can write acceleration is equal to F by M. What is F? So it will be 60 mg. What is M? Sir, M is given to be 3. So I can write, yeah, M, that is 3 G is 10. Sine, what is sine theta? Sine 1 by 2. Simply 1 minus M2. What is M2? Sir, it is 2. 10, 1 by 2 minus 1 into 10, 1 by 2 minus 18, whole divided by total mass, that is 3 plus 2, 5, 6. 6, right? 2 to cancel out. 2 1 2 5 are 10. 2 1 2 5 are 10. So we have now here 60 minus 5 3 are 15. So 15. 10 minus 10 minus 5 minus 18 whole divided by 6. Clear? Wait. Okay, look better. So what I can do right now, 16. So it is 60, right? So I can write 60 here. 60 minus 15, 30, 40. So I can write 48 whole divided by 6. So 10 to it will be 2, 1, 6, 2. So my therefore expression came out to be 2. So this equation I can write F came out to be 23 plus 2. So F came out to be 25. F came out to be 25. So what is F? 25. So option B is correct. Okay, easy. Next numerical is a ball of mass 0.15 kilogram is dropped from a height 10 meter. strikes the ground and rebounds to the same height. The magnitude of impulse imparted to the ball. So we have to find out impulse. What is impulse? Change in momentum. Delta P. Final momentum minus initial momentum. Clear? So can I write delta P, that is also impulse, and impulse came out to be, so if we just a ball is dropped like this, so it will go like this, right? So what is initial? So it is mv. Final is also mv, right? So what will be, it is magnitude. So can I write 2 mv? Yes. So I can write, sir, it would be equals to 2 mv. When the body is getting the body hits the ground, na, so the velocity will be equals to under root of 2gh. So I can write, sir, 2 mass is 0.15 under root of 2. G is 10 and height is how much? 10. 102. So can I write it is 2 into 0.15 into 10 root 2? Yes. So it will be 1.5. Clear? So 2 into 1.5 root 2. So what will be now my answer? That will be 3 under root 2. So can I write it 4 by 2 now? 4.2 is my answer. Option number B. Easy. One more. Here we have. So the two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of the system in terms of acceleration due to gravity. Okay. So this will go like this: acceleration A. Here we have 6g, tension T, 4g. So what I can write? I can write 6g minus T equals to mass, that is 6 into A. First equation. Second equation from this, so I can write T minus 4g equals to 4A. Second one. We have to find out acceleration. So how we can get it? Look, so T came out to be 4A plus 4g. Place the value here. So I guess 6g minus 4A minus 4g equals to 6A. So 6 minus 4, that is 2. So I can get 2g equals to 6A plus 4A. So I can write here 2A equals to 10, 2g equals to 10A. So A came out to be 2 by 10g. That is A came out to be g by 5. A is what? G by 5. That means option B is correct. One more. A block of mass 10 kg is contact against the inner wall of hollow cylinder drum. Okay, that means if we have a drum like this. Okay, what we have now? We have a block. So here we have block. It is 10 kg block. Okay. If we have some radius r. So now, okay, a radius is given to be how much? 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Okay, so nu is given to be 0.1. The minimum angular velocity needed for angular velocity, right? So I can write omega. So it is omega. So we know that. So this is my surface. So it will be my n, and this will be m omega square r. And this would be my what? My frictional force. This will be my mg. Then, so what I can write now? Can I write now that FL should be equal to mg? What is FL? It is nu times n equals to mg. What is n? It is m omega square r equals to mg. Cancel out. So can I write omega came out to be g divided by nu r root. G is 10, nu is 0.1. 0. What is nu? 0.1, right? 0.1 r is going to be 1 root. So it would be equals to 10. 10 root. The answer will be 10, so it is 10 only. This is D, 10 radian per second. Easy? 10 radian per second. Okay. Next one. A particle moves with velocity is acted by three forces shown with the figure triangle PQR. the velocity of the particle. Okay, look now. So let us say it is F1, F2, this is F3. Triangular, right? Can I write F1 plus F2 plus F3? Net force is 0. Net force is 0. Clear? If it is 0, so my A will be 0. So V will be what? Constant. Option D remains constant. It will remain what? Constant. Done? This is how we can manipulate these things, right? And I guess these are very easy to us. Next numerical. Okay, it's big numerical. Okay, a flying object. A object flying in air with velocity this much suddenly breaks in two pieces. Okay, it breaks in two pieces whose masses are in the ratio of 1:5. That means the total mass of the system is 6. It gets divided into 1:5. The smaller mass, that is 1, flies off with a velocity like this. The larger the velocity of the larger piece will be. Okay, as we know that it just breaks, right? So there is a no external force being applied on it, so all this kind of breaking is due to the inner forces. So we can do the what? Conservation of momentum. Can I write momentum initial equals to momentum final, mass into velocity? So I can write m1 v1 plus m2 v2. What is m1? Sir, 6. It will be 6 now, right? What is v? V is given to be 20 I cap plus 25 j cap minus 12 k cap equals to m1. What is m1? 1. 1. What is velocity of it? Smaller. Okay, it is 100. 100 I cap plus 35 j cap plus 8 k cap. What is m2? 5. Can I write 5? Velocity is v, right? So can I write it is 120 I cap plus 150 j cap 6 to the 12 72 k cap equals to 100 I cap plus 35 j cap plus 8 k cap plus 5 v. Can I write 120 I cap minus 100 I cap plus 150 j cap minus 35 j cap minus 72 k cap minus 8 k cap equals to 5 v. 100 minus 120 minus 100, I can write it as a how much? 20 I cap plus 150 minus 30. It is 35, no? 150 minus 35. How much I will get? So I can write 10 minus 5, that is 5. 4 minus is 1 and 1. Okay, 1 j cap minus 72 minus 8, it is 80 k cap whole divided by 5 equals to v. 5 under 5, 5 4 is 20. 5 2 is 10, 5 3 is 50. 5 under 5, 30. 5 3 is 30. So I can write 4 I cap, right? Yeah, what I can write now, it is 4 I cap plus 23 j cap minus 16 k cap. 4 I 23 j. I think option A. Yeah, option A is correct. Option A is correct. Okay, which of the following statements is incorrect? Rolling friction is smaller than sliding friction. It is true. Limiting value of static friction is proportional to normal friction. It is true. Frictional force opposes the relative motion. True. Coefficient of sliding friction has a dimension of length. No. Coefficient doesn't have any dimensions. No. So option D. Option D is correct. Okay. The block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration towards the right. Okay. The relation between A and theta. Okay. So we need to, okay, to remain rest, right? So it is m. So I can write this will be mg theta. So mg cos theta, mg sine theta normal reaction. If this is A, so this would be my MA, theta force. So this is my theta. This will be MA cos theta. And one more, that is MA sine theta. So that means my MA cos theta should be equal to mg sine theta. Second equation is equal to my n should be equal to MA sine theta plus mg cos theta. Second, right? So to be a rational, I need this type of things, right? So from this figure, can I write m cancel out? So my tan theta equals to A by G. My tan theta will be equals to A by G. Clear? So we don't have any, no, okay, we don't have any option for it, no? Yes. This is the kind of, yeah, this is a relation, right? Relation, that is tan theta is equals to A by G, or you can write A equals to G tan theta. No issue. This is one more modification of it. Clear? Okay, next numerical is like, okay, two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitudes of acceleration of A and B immediately after the string is cut are, okay, so first of all, is it m? So I can write here, so it will be mg. Upperward we have tension T, lower what we have now, we have 3 times mg. Here what we have one more tension is kx also, right? So can I write for this particular one, can I write T is equal to mg? For this one, can I write kx is equal to one more T also, right? 3 mg plus T, and T is mg, kx is equal to 4 mg. Before cutting, if I cut now, after cut, T is 0. If T is 0, this one, if T is 0, clear? If now T is 0, so first of all, can I write like it is mg, then m, it will go now with A acceleration. Can I write mg equals to ma, cancel out, so A equals to g. A is g, right? Okay, that means this will be incorrect. Now these are, let's find out for this one now. Okay, so I will take this one only. Clear? So can I write kx equals to 3 mg plus 0? Okay. So yes. So what I need to find out now? So kx came out to be 3 mg. Kx come out to be 3 mg. Can I write now? My net forces, that is kx minus 3 mg equals to m into a. What is kx? Is 4 mg. So it is 4 mg minus 3 mg equals to, it is 3. 3 ma, m cancel out, 4g3, it will be g by 3 equals to a. G by 3. So I guess option A is correct. Option A is correct. Next numerical, if you have some doubts, you can ask me, right? So one end of the string of length L is connected to a particle of mass m, and the other end is connected to a small peg on smooth horizontal table. If the particle moves in a circle with velocity v, the net force, okay, that means if we have a circular frame like this, we have particle peg here, we have particle like this, right? So it's a radius r, particle is moving with velocity v. Okay, what will happen? So if it is tight enough now, so we will having a tension here and one force, that is mv square by r outwards. So what is net force? So the net force on the particle. What is net force? So net force will be either T or mv square by r. Only one of the forces, right? Incorrect, only T. हेलो बेटा, लेट हो आप, है ना? इस पे कंसंट्रेट कर रहे हैं आप, आपने ये चैप्टर पढ़ा होगा. So option D, yeah, option D, T is the answer. Next one. So in the a rigid ball of mass m strikes a rigid wall at 60 degree, but the degree is with now the horizontal plane, right? So if we need to calculate the change in momentum in the horizontal, it would be 2mv cos theta. With the vertical, it is 2mv sin theta. So we have to find out the impulse. Impulse is change in momentum, right? So impulse is equals to change in momentum, and that is equals to 2mv cos theta. 2 is 2, mass is given to be m, v is v, cos theta, cos 60 is 1 by 2, cancel out. So my impulse came out to be how much? It is mv only. It is mv only. So my option A is correct. Clear? Okay, now this one. A car is negotiating a curve on a road R. It is bending, okay. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is nu s, the maximum safe velocity. So we have to find out safe velocity, right? So there are three parameters or three different cases of banking of road. One is only banking, second is only friction, third is friction plus banking. So first of all, I will make the road, right? So if this is my road, so if this is my car with mass m, so this would be my what? Mg cos theta. This is my normal reaction force N. Clear? And this would be my centrifugal force mv square by r. Done? And look now, if this is mg cos theta, so most probably this would be my how much? Sir, mg sin theta. And there would be one frictional force which is balancing this mv square by r, na? So my frictional force will be like this only, and this will be how much? Fl or F simply. F is nu n. But we need to balance these forces. Clear? So I guess I can do it like this now. So if this is my f only, so can I write if this is n, so this is one component of n, that is n sin theta. So it would be now nu n cos theta. Can I write now, sir, n cos theta, that is this one, n cos theta. So I can do like this. This will be mg, then nu n sin theta equals to mg plus nu n sin theta. First equation. The second one, can I write? It would be mv square by r equals to n sin theta plus nu n cos theta. Second equation. So now rewrite the two equations. This one first of all. This one. Now first of all, I will write this one only. I can write mg is equals to n cos theta minus nu n sin theta. Second one, mv square by r equals to n sin theta plus nu n cos theta. Now I will divide these things. Divide. M cancel out. Look, n cancel out. So I can write, sir, it will be g. I will write here, right? So I can write, sir, it will be g. Not no visible. It will be g whole divided by v square by r equals to, let us divide by cos theta. So it will be 1 minus nu tan theta whole divided by tan theta plus nu. Now, what I can write, I will reciprocal it. So it will become now, so let us say g by 1 into r by v square equals to 1 minus nu tan theta whole divided by nu plus tan theta. I need to v, right? So I can write v square equals to GR 1 minus nu tan theta whole divided by nu plus tan theta. If I just transfer this 2 now, it will become now 1 by 2. I guess GR, I think I had some mistake, right? Wait. I can take it upwards. Yes. Yeah, I need to change this one also, right? I haven't. I need to change this one also. So if I can write here v square, it will be equals to GR then nu plus tan theta whole divided by 1 minus nu tan theta and 1 by 2. So GR nu as, I guess, option C. Yeah, option C is correct answer. Option C is correct. Next one. Two stones of masses m and 2m are whirled in horizontal circles. So that means 2, 1, 1. Mass m, the heavier one is radius r by 2, that is 2m. This one is m. Radius r by 2, radius r. The tangential speed of lighter one. Lighter one is, let us suppose, what is lighter one? This one. Speed v1 and heavier is v2. So v1 equals to n times v2. It is given to us. Same centripetal force. So I can write m1 v1 square by r1 equals to m2 v2 square by r2. m1, let's suppose it is a smaller one, right? What is m1? m1 is m. What is v1? v1 is v1 only. Square. R is given to be r. m2 is 2m. v2 is v2 square divided by r2 is given to be r by 2. So m cancel out. v1 is n square v2 square divided by r equals to 4v square divided by r. R cancel out, v2 cancel out. So n square came out to be 4. That is n is 2 only. N is 2 only. Right? We can do like this. A plank with a box on it at one end is gradually raised, okay, about the other end, okay, as the angle of inclination with the horizontal reaches 30 degree, maximum one, angle of repose. The box starts to slip and slides 4 meters down the plank in 4 seconds, okay. Displacement is given, time is given. The coefficient of static friction. So this is easy, no? Static friction. How? So we know that tan theta equals to nu s. So what is theta? Tan 30 degree. Nu s. Nu s 1 by root 3. That is 0.6. 0.6, that means, yeah, this could be answer or this could be answer. Now we have to find out the kinetic friction. So if this is my block, this is m, so this would be my theta, mg cos theta, mg sin theta, fk, nu k times n, nu k, m is how much? mg cos theta. Can I write my net force will be equals to, sorry, it will be mg sin theta minus nu k mg cos theta. Yes, sir. So is it equals to m into a? Mg sin theta minus nu k mg cos theta. Okay. Look, m cancel out. A came out to be, sorry, it is g is 10. Sin 30 is 1 by 2 minus nu k. G is 10, cos it is under root 3 by 2. 2 5s are 2, 1, 2 5s are 10. What is A? S equals to ut plus 1 half of at square. S is given to be 4. U is 0 because we have, it started with motion, right? U is 0. So it is 1 by 2, A is 8, T is 4 into 4. Cancel out to the 4. So, what is my A now here? A came out to be 1 by 2. So it is 1 by 2 equals to 5 minus nu k 5 root 3. So I can write nu k 5 root 3 equals to 5 minus 1 by 2. 10 minus 1 by 2 nu k 5 root 3. So it would be nu k equals to 9 by 2 into 1 by 5 root 3. Clear? So now I will simplify it um, into root 3 into root 3. So how I can get it now? Nu k. Look, 9 root 3 whole divided by 2. Or I can do one thing now. Why this? I can do one thing. Look, nu k equals to 9 by 10 root 3. 0.9 by root 3. Clear? It will be 0.5. 0.5. Yes. So I guess 0.6 is option D. Option D is correct. Next numerical. A block A of mass M1 rests on a horizontal table. Okay. Okay. So this is my table. So I will make a table of it. Okay. What I have now? I have a block A. Okay. Here is my block A. Block A. It is mass is M1. Horizontal table of here we have pulley. Here we have what a block B with mass M2. The coefficient of kinetic friction between the blocks. So we have here nu k. Tension, we have to find tension. If it is going downward by acceleration A, this is how much M2G tension T, tension T. Clear? So it would be M1G. So what I can write this acceleration A. So T minus nu Kn equals to M1A. So what is tension? Tension is M2G also. So I can write T minus nu K. This N. N is M1G equals to M1A. Now from this equation can I write it is M2G minus T equals to M2A. Second equation. So my first equation. And what I need to find out? Tension T. So tension T, here I will get my acceleration here, right? Yes. So can I write that it is M2G minus T divided by M2 equals to A. Okay, right now the tension minus nu K M1G equals to M1A. What is A? A is M2G minus T divided by M2. So T came out to be M1 M2G minus M1T whole divided by M2 plus nu K M1G whole, yeah, M1G. Now can I write like this now? The T came out to be M1. So I can write M1 M2G minus M1T plus nu K M1 M2G whole divided by M. Yeah, this is M2 only. M2 only, right? Is it M2 only? Clear? I had done something wrong. Yes or no? No, no? Okay. It was M2G minus T equals to M2 equals to A. Okay, A. So T came out to be. So I can write it like this. So plus like this. So it came out to be T, I can transfer T here, no? So it will be Tm2. So Tm2 plus M1T equals to M1, M2. I will take common G. Now what I have 1 plus nu K. So T came out to be M1 M2G 1 plus nu K whole divided by M1 plus M2. M1 M2 1 plus nu K into G, option A. So option A is correct. Option A is correct. This one. A system consists of three masses M1, M2 and M3 connected by a string passes over a pulley P. The mass M1 hangs freely and M2 and M3 are on a rough horizontal table. Okay. The pulley is frictionless and then negligible of mass. Okay. The downward acceleration of M1 is, so we have to find out this acceleration A. So if it is A, this is tension T. Tension T should be nu K N. N is how much? M2G. Nu K, it will be how much? That is force, no? Nu K M3G. So T is equals to M1, M2 is same, right? So can I write 2 times nu K mg? Yes. This one now. What is this? This is mg only. I can write mg minus T equals to M into A. Mg minus T is equals to 2 nu K mg equals to M into A. M cancel out. So it will be G minus 2 nu K times G equals to A. So I need to find out A, right? I need to find out A. Okay. But here is 3A, na? It is total mass here. It is 3A. 3A. It is, yeah, divided by 3. So I can take G common. 1 minus 2 nu K whole divided by 3. It's A. Which one? C? Yeah, C is correct. C is correct. Next numerical. So what we have now? We have the force F acting on a particle. One second, I need to check the timing now. Okay, 1 hour to go. A force F acting on a particle of mass m is indirected by a force time graph shown below. The change in momentum of the particle over the time interval from 0 to 8 seconds is. So basically, we have the graph is given to us. We know that the area under the graph gives us the impulse and the change in momentum also, right? So for this one, it is 1 by 2. 1 by 2 base is how much? 2, and it is going to be 6. This one is it 2 into minus 3. This one 4, it is 4, 8. It is 4 into 3. So this would be 6. This is 6 minus 6. So I can write 6 minus 6 plus 12. Answer is 12, right? You can see answer 12 is correct. Next one. A balloon with mass m. So we have a balloon with mass m descending down with acceleration a. So it is going with a. So force will be upwards, now the thrust will be upwards. Okay, done. So G is also downwards. How much mass should be removed? Let us suppose m dash. It will go then A, then G. Clear? Same F will be upwards. Now, can I write for this one? Force, that is F equals to mg. So what is force? It will be F minus m dash into G equals to m into A. What is m? M into A. Clear? So I need to find out m dash. Can I write F minus mg minus m dash G equals to ma minus m dash A. So F minus mg plus m dash G equals to ma minus m dash A. So I can write F. Clear? So how we can do it now? How we can do it now? Okay. So from this one, what is this one, right? So I can write mg. Yes, sir. So I can write that mg is downward is mg minus F equals to m into A. So F came out to be mg minus ma. So I can write mg minus ma minus mg plus m dash g equals to ma minus m dash a. Cancel out 1, 1, 2. I can write m dash g plus m dash a equals to 2 times ma. Yes. So I need to find out a, right? Yeah, a. M dash. M dash equals to a plus g equals to 2ma. So m dash is equals to 2ma divided by a plus g. This is my answer. 2ma, a plus g. Yeah, option number A is correct. Next numerical. Three blocks with mass m, 2m and 3m are connected by string as shown figure. After an effort, figure F is applied on block M. The masses move effort at constant speed. Okay, speed is constant. Net force will be zero, na? Speed constant, so force is zero. Next one. An explosion breaks a rock into three parts in a horizontal plane. Okay, two of them go off at a right angle. Okay, that means it will go like this: m1, m2. It is 1 kg and speed is 12 meters per second. M2, what is M2? 2 kg and speed is 8 meters per second. The third one like that, M3, and it is 4 meters per second. We have to find out what? Mass. Okay, there is no external force, so we can do one thing. We can just conserve the momentum. Okay, so I can write momentum first plus momentum second plus momentum third equals to 0. So momentum third equals to minus P1 plus P2. The mod will be equals to P1 mod plus P2 mod. Clear? So how I can write it now? Look, what is P1? M1 V1 square plus M2 V2 square root, right? So I can take here right now. M1, what is M1? M1 is given to be 1. So I can write 1 into 12 whole square plus what is M2? M2 is given to be, what is M2? 2 into 8 whole square root divided by, we don't have any, na? It is P3. P3 is what? M into 4. 144, 16 square. Clear? So it is 16 square. So 16, what is 16 square? 36. 6 is 5. It is 256 root whole divided by 4 equals to M. It is 400 root divided by 4. 20 by 4. So my answer is 5. D, 5 kilogram is my answer. Easy now? Next one. Okay, I guess from this onwards, we will do in the next class. Okay, for today. Thank you. Thank you very much, Vito. Bye.